Hi there, and welcome back to Del Mar Learning's Residential Construction Academy for Carpentry. My name's Rodney. In our last program, we set the forms and placed our slab. So, with our foundation completed, our next project includes installing the subflooring and framing the walls. First, let's talk a little about the materials we'll need for our job. Both subflooring and wall framing call for lots of wood. And as you look around our site, you'll notice that the vast majority of these homes use metal. Why? Well, for one, metal is less expensive than wood, and two, it's termite proof. So, needless to say, it's becoming a very popular alternative to wood. With that in mind, we're going to be bouncing around a bit over the course of today's program. A portion of the material will be covered here on this southern site, and the rest will be covered in a secondary location in the northeast. Alright, we have a lot of material to cover in a very short period of time, so as we work our way through this lesson, be on the lookout for these carpentry buzzwords. Subflooring, sill sealer, floor joist, beam pocket, sole plate, rough opening. Subflooring is a working platform and provides the base for our finished floor, walls, and roof. So before we begin, it's important to check the squareness of the foundation perimeter. And if we find that all of the distances aren't the same, we'll need to make the necessary adjustments before moving on. Let's begin by looking at the horizontal members of the floor frame. These are called sills, mud sills, or sill plates. And though their installation varies slightly depending on where you live, you'll typically find yourself using 2x6 pressure-treated lumber for this job. Begin by snapping a chalk line, which will mark the inside edge of the sill on the foundation wall. Measurements are important here, so make sure to check it for length and square it off as needed. Next, cut the sill to the proper length and place it at the correct distance from the end of the wall. Now, holding the sill against the anchor bolts, mark that location with a square. Now move over to your foundation edge line and measure in from that chalk line, and all the way back to the center of the anchor bolt. After you've made this measurement, mark that location on the sill. This mark becomes the center of the anchor bolt hole. Next, we'll need to drill holes in the sill plates so they'll fit over the anchor bolts. As you're drilling, make sure that the holes themselves are 1/8 of an inch larger than the anchor bolt. This will make it much easier to fit the sill plates later on. Once you've drilled the holes, move over to the foundation wall and install the sill sealer. Sill sealer is an insulating material used to seal against drafts, dirt, and insects. It comes in rolls that are 6 inches wide and 50 feet long. Push the sealer over the anchor bolts, stopping just outside the chalk line so that the chalk line itself is still visible. After the sealer has been placed, go ahead and place the sills over the anchor bolts, making sure that the edge of the sill is on the chalk line. Once that's checked, secure the sills in position with washers and nuts. Be careful not to over-tighten the nuts. This could lead to cracks in the wall if the concrete is not thoroughly dry. Alright, our sills are in place and secured, so let's move ahead and mark the location for the floor joists, which are typically found on the sill itself. A floor joist is a wood member that provides support to the subfloor system of a house and is supported by a girder. As you begin measuring out the spacing for the joists, keep in mind that joist spacing is determined by the following formula: the distance minus half the thickness of the joist member. So if our joists are, let's say, 2x10s at 16 inch on center, we would measure 15 1/4 inch. After you've finished making your calculations, mark and square a line across the sill, placing an X to indicate which side of the line to place a joist. When members are placed on the correct side of the line, they will cover the X. Before we cut and nail the floor joists, one last thing. We have to check the blueprints for the locations of the floor openings and the partition supports. Once we've found those locations, we can install the floor joists. Girders are responsible for supporting floor joists and are designed to carry a tremendous amount of weight. To begin, mark the location of the girders on the sill plate and notch them out. This will give you access to an opening in the concrete known as a beam pocket. You'll eventually place the ends of the girders within these beam pockets. Next, measure, cut and fasten or ply several girders together. Remember, girders need to carry a lot of weight, and plying them together will give you added strength. Also, unless they're made of steel, girders almost never make it across the full length of a house, meaning that the girders are cut into two pieces with an overlap that will be used to join it together later on. Let's begin by raising the center girder. First, the crew raises one end of the girder into a beam pocket. A pipe column is then placed underneath the girder for support. These pipe columns are permanent support and will be nailed into both the concrete and the girder later on in the process. Temporary wood braces are then placed on top of the girder in order to keep it in place until it can be leveled out. Next, the other end is placed in the opposite beam pocket, and a second pipe column is placed underneath for support.
Oh, I see. It's hitting the concrete.
In order for the overlap to fit together, adjustments are made on either end, and then the two pieces are fastened together at the overlap. Once the girder is in place, it's leveled and then marked for the locations of the floor joists. Floor joists can be made of solid lumber or they can be pre-manufactured. In our case, we'll be using an engineered wood product known as TJI, which stands for Truss Joist Institute. Unlike solid lumber joists, TJIs are manufactured straight, so there's no need to sight and mark the crown edge on each joist. TJIs are placed along the sill, 16 inches on center, and span the entire width of the building, meaning that you won't need to concern yourself with overlap. Sliding pieces of TJI over each other makes initial placement go much faster. Once each piece of TJI is placed into permanent position, it's toe-nailed to both the sill plate and the girder with a nail gun. Alright, it looks like we're making really good progress here. Our TJIs look great, so I'd say we can begin adding a subfloor. For this house, the subfloor product we'll be using is called OSB, which stands for Oriented Strand Board. It's one of the newer alternatives to the traditional plywood, and we're using a tongue and groove system for added strength and support. Start by snapping a chalk line 4 feet from the outside edge and perpendicular to the joists. Sometimes it's not a bad idea to put construction adhesive on top of the joists before applying the subflooring. This helps eliminate squeaky boards and add some strength to the floor. Only use construction adhesive in well-ventilated areas away from all flames and sparking equipment. Avoid getting the adhesive on your skin. Start with a full panel, and as you lay down the first row, make sure that each sheet of OSB fits tightly together. Start the second row with a half sheet in order to stagger the end joints, and then continue with full panels to finish the row. For this installation, a sledgehammer is used to tighten the joints between the tongue and groove. And this is important because if a gap is created within a row, the next row will be very difficult to lay out straight. Once the sheets are in place, they're screwed into position. During the wall framing phase of construction, the building really begins to take shape. Wood wall framing has been around for many, many years. Wood is very strong, yet easy to work with, and when it's installed and maintained properly, it should last indefinitely. Today, we're going to be working with pressure-treated lumber, which means that wearing eye protection and a particulate mask is a must. And remember, you should never, ever burn pressure-treated lumber. The fumes and smoke can be extremely toxic to you as well as your coworkers. Okay, before we begin framing our walls, I want to spend a moment talking about the tool I have in my hand. This is a nail gun, and it's a very popular tool for fastening framing members. They're fast, powerful, and extremely dangerous if not used properly. So, with that in mind, let's go over some nail gun safety tips. To prevent eye injuries, always wear OSHA-required Z87 safety glasses with permanently attached rigid, hard plastic side shields. Always wear other personal protective equipment including hearing protection and a hard hat. Always remove your finger from the trigger when you're not driving fasteners. Never carry the tool with your finger on or under the trigger. Keep your hands or other body parts away from the area that the fastener will penetrate. Remember, a nail gun will eject a fastener if the safety element is bumped. And finally, read the manufacturer's instructions for safe operation, because the best way to protect yourself is by knowing your tool. In order for us to build both the exterior and load-bearing walls, we need to become familiar with the components that make up the walls. So, let's review some key terms. A stud is a vertical member running between the top and bottom plates. Pre-cut studs for an 8-foot 1-inch ceiling are 92 5/8 inches long. Plates are horizontal members placed at the top and bottom of the wall. The plate at the top is called the top plate, and the plate at the bottom is called the sole plate. A trimmer is a shortened stud that supports the headers. Trimmers are fastened to full-length studs on either side of a rough opening. The king stud is fastened to the trimmer. The header is a support beam over a rough opening. Cripples are shorter studs placed above and below a rough opening. Sills are horizontal members located under a window opening. Corner posts are the same length as a stud and are used for the corner of a wall frame. A partition intersection is a combination of 3 blocks sandwiched in between 2 studs. Now that you know some of the key terms, we can begin cutting and assembling the trimmers, partition intersections, headers, corner posts, and any other components that will make up our wall frame. By the way, the locations of all of these components can be found in your blueprints. Let's assemble all of our wall components, starting with trimmers. We'll begin by cutting the trimmers on either side of the wall openings. Their length is determined by the height of the rough opening minus the sole plate thickness. For example, if we look at our door schedule, we'll notice that a rough opening for a certain door is 6 feet 10.5 inches. So we take 6 feet 10.5 inches and subtract the sole plate thickness, which is 1.5 inches. Giving us an end result of 6 feet 9 inches, and we cut our trimmer to that length. Trimmers are always marked according to their length. Once you've cut and marked all of your trimmers, nail them to the king stud. Start at the bottom and work your way up, keeping the sides flush and placing nails every 16 inches on alternating sides. When you finish nailing the pieces together, neatly stack and place them to one side for later use. After cutting the trimmers, use the leftover ends of the studs for blocking material. Headers can be made from several materials, including solid lumber, glue lams, laminated veneers, laminated stranded lumber, built-up headers, and others. Header information is found on the window and door schedule of the blueprints. The length of your header is equal to the width of the rough opening, plus the thickness of the 2 trimmers. So, looking at our door and window schedule, we see that we're given a rough opening of 38 inches. We take that number and add it to the thickness of the trimmer, which is 1.5 inches on each side, or 3 inches total. 38 inches plus 3 inches equals 41 inches. So our header length is 41 inches, and we'll cut it to that length. After cutting our headers to length, we need to measure their thickness. When we nail the headers together, they need to have a combined thickness equal to that of the wall. In our case, our wall is 3.5 inches thick. However, our 2 headers together have a thickness of 3 inches, meaning that we need to make up a 1/2 inch somewhere. And we do that by laminating the headers. That is, we place a 1/2 inch piece of plywood in between our side members and nail them together, giving us our 3.5 inch thickness to match the wall. When cutting that 1/2 inch of plywood, you'll want it to be slightly smaller than the header size. Corner posts are the same length as the studs and are constructed whenever one wall ties into another. The total number needed can be found in the blueprints. To make a corner post, we'll start by laying 3 12-inch to 16-inch blocks in a row. Lay the 3 blocks flat with their total length equaling that of a stud. Now, find a stud that's the same length as one of your wall studs and lay it on top of these 3 blocks. Next, using a combination square, flush these 3 blocks with the stud and nail them down. When that side is finished, turn the stud over and nail a second stud to the other side of the block, keeping everything flush as you go. Once you're all finished, stack them neatly aside for later use. Whenever interior partitions meet exterior walls, extra framing is needed. That's where partition intersections come into play. The total number of interior partitions that intersect can be found in your blueprints. To make a partition intersection, start by laying 3 12-inch to 16-inch blocks in a row. Lay the 3 blocks on edge with their total length equaling that of a stud. Run another block perpendicular to the other 3 to help support the stud while nailing. Finally, nail a stud on both sides of the block edges, using a square to make them flush. After you've pre-assembled all of the major components in the wall frame, you should shift your attention to the matter of placement. Exterior walls are usually 4 inches or 6 inches wide. In our case, we're going to build 4-inch walls. So we begin by measuring in from the outside of the concrete, snap chalk lines, and mark our wall placement. Measure in 3.5 inches from the outside of the exterior wall and place a mark on the floor. Your marks need to match up with the exact measurements of the building, so check your work and make any necessary adjustments before moving forward. After determining that all of your measurements are accurate, use those marks and snap a chalk line to mark your wall line. Once you've made your wall line, check it for squareness by taking some diagonal measurements. With our wall lines in place, we can begin planning a sequence for raising the walls. Usually, the longer ones are assembled and placed first, followed by the shorter ones. This is a sole plate. It's the bottom plate of a wall and works together with the top plate to tie the entire wall together. To place your sole plates, lay the first one into position along your wall line. Using a square, mark the anchor bolt location and measure the distance from your wall line back to the bolt and mark it on the plate. Next, drill a hole through the sole plate, making it about 1/8 of an inch larger than the size of the anchor. Then, place the sole plate over the anchor bolts, making sure that the edge of the plate is on the line. And as always, make adjustments where necessary. Remember to notch out any pipes that could be in the wall as you go. After your first sole plate is in place, continue placing the rest of them around the perimeter of the building, making sure that the splice is on the center of a stud. Once that's finished, cut the top plate and lay them side by side. It's not necessary to drill the top plate for anchors or pipes. A few words about rough openings. A rough opening is a measured opening in a wall where a window or door will eventually be installed. These openings vary according to the size of the window or door, as well as from one manufacturer to the next. And remember, when it comes to rough openings, width is just as important as height, because our window and frame, or door and jamb, will need to fit inside the wall as well. All right, let's measure our openings. We should be able to find the correct measurement for all of our rough openings right here in the blueprints. But if you can't find them there, try looking in the window and door schedule. So, using the measurements found on the blueprints or the ones you received from the manufacturer, find the center of the rough opening from the outside edge of the wall and mark this on the sole plate with a centerline mark. Next, take the rough opening measurements and divide it in half. The resulting number marks the center of the rough opening and should be placed on the center line. Trimmers and studs are next. Trimmers are marked on each side of the rough opening with a T, and the stud is marked on each side of the trimmer with an X. Next, place a C at all of the window rough openings adjacent to the trimmers. This marks your cripple stud, which helps carry the load of your sill during assembly. Moving on to the partitions, first, look at your blueprints to find exactly where the interior partitions intersect the exterior wall. And once you've found that location, mark it with 2 studs and place a 3.5-inch block between them. Corner posts are marked in pretty much the same manner as the partitions, with 2 studs and 1.5-inch blocks between them placed on the ends of the wall. Alright, we're almost finished. All we need to do now is mark the studs at 16 inches on center, and we're done. We'll find these marks by hooking the end of the tape measure over the end of the exterior wall. Then measure over 15 1/4 inches and mark that spot as the leading edge of the first stud. Then, holding the end of the tape on the 15 1/4 inch mark, continue to mark the rest of the studs at 16 inches on center, putting a mark and an X on the same side as the first stud. Finally, take out your square and put this mark on both the top and bottom plates. As you're finishing marking your studs, some of the marks might fall inside a window, and in those cases, mark the location with a C, which stands for cripple stud. With our rough opening completely measured and marked, we can move ahead and begin to assemble the wall. This job requires quite a few steps, so take your time and do it right the first time. First, take the sole plate off the anchor bolts and turn it on edge with the marks facing toward the top plate. Next, place the top plate approximately 8 feet from the bottom plate with the markings facing the bottom plate. Once you've finished lining up your plates, place the studs on edge in between the plates with the crown up. Do not use twisted or bowed studs. These can be used for blocking or bracing only. Now, place the partition intersections at their location, making sure that they face towards the wall where they'll eventually be fastened after the wall is raised into position. Next, we'll assemble the rough openings for the doors. Begin by placing trimmers and king studs between the plates and on each side of the opening. Then place the headers and cripples according to the layout, and fasten all the components together using 16-penny common nails. To assemble the rough opening for a window, we'll nail the trimmers and the header to king studs, making sure that the header is nailed above the trimmer. Next, nail the king studs and header to the top plate, and the king studs and trimmers to the bottom plate. Cripples are then nailed to each trimmer. Now, holding the sill above the bottom plate, transfer the layout to the bottom of the sill and nail it to the cripples. After you've done that, go ahead and nail the remaining cripples to the sill and bottom plate. After all the components have been nailed in, the last job on our list is to assemble the double top plate. But before we nail it on, we need to measure the setback. First, move back 3.5 inches from the end of the wall. That will give you enough room for the perpendicular wall to tie into this one. Make joints on a stud, but stagger them at least 4 feet from the first plate. After measuring the setback, nail on the double top plate. At this point, we're just about ready to raise our walls, but before we do, let's address a couple of quick issues. The first one has to do with connectors. Before raising a wall, it might be necessary to nail connectors that wrap under the sole plate and over the top plate. Check the blueprint to see the type and amount of connectors to use, and remember that these connectors should only be fastened to one side of the stud until the walls have been straightened and plumbed. The second issue is sealant, which needs to be placed on the floor surface. Why? Because it's important that we create a seal between the sole plate and the floor after the wall is raised. With all of our wall components measured, cut, and assembled, we can move on to the final phase of wall framing, and that's raising the walls. This job is going to require several crew members, with one person per 10 linear feet of wall. We could use a wall jack to lift heavy walls to a vertical position, but most of the time, walls are assembled in sections that are small enough to be lifted into place by hand. Begin by lifting the wall from the top plate side into a vertical position, making sure not to place it on top of the anchor bolts. Once the wall is vertical, lift it by hand or use a pry bar and place it over the anchor bolts. Put the edge of the bottom plate along the chalk line and fasten it down using washers and nuts on the bolts. Next, we'll brace the walls plumb, using 2x4s for braces.
A little out, like a ½ inch.
Begin by plumbing the end of the wall and place a temporary diagonal brace on the interior side of it. Once the wall is plumb, nail it before removing any sort of prying force. After your first wall is in place, continue to lay out and set all the exterior walls in the same manner. With the walls raised, move to the corner and nail the lapped top plate joints into the corner. Once that's finished, structural sheathing is used to permanently brace and support the corners and walls of the structure. To finish the wall raising process, install connectors over the top and bottom plates, and you're done. Wow, we covered a lot of material today. So if something we covered didn't click, please feel free to review that section again. Once the exterior walls and subflooring are in place, you really begin to get a sense of what the finished product is going to look like. In our next program, we'll continue the residential construction process with a first-hand look at truss installation. I'm going to call it a day. For Del Mar Learning, I'm Rodney Wiltshire, and I hope to see you back here real soon.